Hey guys, today we're going to be going over this problem. So it says that the lattice energy of NaI is negative 686 kilojoules per mole and the enthalpy of hydration is negative 694 joules per mole. Calculate the enthalpy of solution per mole of solid sodium iodide and describe the process to which this enthalpy change applies. Okay, so one thing I when I was solving this problem noticed is this has so many concepts in it, and it's really important that you understand. So I'm gonna start off by going over this picture again. So it says that the lattice energy is negative 686, enthalpy of hydration, and okay, well, from what we learned before is that the enthalpy of hydration is equal to the delta H2 plus T delta H3. And we know that delta H1, we see that we're increasing in order to expand this solute, right? So we're breaking here, and then once again here you're increasing to expand the solvent. You're breaking, and then here in step 3 you're forming. And the reason we can combine delta H2 and delta H3 is because you have to account for the expanded solvent in both of these containers, and in order to measure that you would have to use a combination of both. So I just wanted to touch up on this before we get started because you're going to need to have an idea of this to do this problem. Okay, so we're going to actually touch up back to a couple chapters before. We're going to have to use Hess's law to solve this. So it's telling us the lattice energy is negative 686 kilojoules per mole, and it's telling us the enthalpy of hydration is negative 694 kilojoules per mole. But then it says to calculate the enthalpy change of solution. So the delta H solution, which in this case is going to be equal to our delta H1 plus delta H2 plus delta H3. And we already said that this is going to be our delta H of hydration, so you can sort of make the connection on what this is going to be. But let's start. So we're going to start by using Hess's law. So we have sodium iodide here as a solid. And remember, we said that this step 1 is a breaking process. So this is going to yield to sodium and iodine. And now we know that lattice energy is the energy that's formed when a bond forms, when it snaps together. So our delta H for our lattice energy is going to be negative 686, but times the inverse, because it's actually the opposite, right? It's actually the opposite process of lattice energy because it's breaking apart. So instead of negative 686, it's going to be positive 686 kilojoules per mole. And now for our next part, we have our delta H of hydration. So that is our sodium with a positive, our sodium ion, and our iodine ion, both as gases. And these are, by the way, are coming from here. And then that in part 3, and how we just discussed with the graph, how right here, how it forms into this solution. We have to consider that when it's in the solution with the solvent, it's now going to be aqueous. So it's going to go from gaseous into aqueous. So it's going to, instead of being sodium ion and gaseous, it's going to be an aqueous sodium ion plus an aqueous iodine ion. Okay, and that is going to be our delta H of hydration, which is going to equal our negative 694 kilojoules per mole, and I say negative 694 because it says it right here. Now we have the total sum, the sum reaction is that NaI as a solid will go to Na plus aqueous and iodide aqueous. And the total H of solution here is going to equal to negative 8 kilojoules per mole.